All right, scholars, I'm going to help you get started on the interaction with new material. Be making a prediction for one of these colors here, and then you'll complete it, and I'll remind you how to check your work. Okay, so interaction with new material. Example 1, Ms. Fleck conducted a probability experiment in a previous class where scholars picked a color paper out of an envelope and recorded the frequency in the table below. She doesn't remember the amount of each color in the envelope, but she does know that there are 10 pieces of paper. Determine the number of each color without opening the envelope. So making some annotations here, we know that there are 10 pieces of paper in the envelope, not this much. This is just how many times she conducted the experiment, and they want us to make a prediction for each color. Okay, so just want to let you know in advance, purple, red, and blue are going to lead to decimals that you'll need to round to a whole number. Green will not. I want to model that for you, so I'm going to go ahead and make a prediction for purple. So my first step is to find my total number of outcomes. In this case, they don't say that Ms. Fleck conducted 100 experiments or 50 trials. All it says is, right, she did an experiment, and then here's the data. So we need to add on our own, okay? So first we add that 11. So there was 11 times she selected green. And then what's next? Purple is 12. Then we got red is 5, and then the last one is 27 blue. So you add all that up. You could check in your calculator, scratch paper. 11 plus 12 is 23, plus 5 is 28, and then plus 27 is 55. Next, I'm looking for my desired result, and since I'm making a prediction for purple, that is going to be 12. So now I'm ready to set up my equation and make this prediction. So the probability of selecting purple, a purple paper from this envelope, is equal to, setting up my proportion box, equal sign in the middle, got my fractions, labeling it, total number of outcomes, and our desired result is purple. So we said the total outcomes, or the total trials, is 55, and out of those 55 trials, she selected purple 12 times. Now we want to make a prediction, and since there are only 10 pieces of paper in this envelope, that's how many total outcomes we're going to put. And we're putting an X up here because right now we have no clue how many pieces of paper are purple out of the 10 pieces of paper in the envelope. So I want you to press pause on this video, cross multiply and divide, and we'll check back in a bit. All right, scholars, welcome back. I wanted to continue right here just to ensure that if you're using a calculator, you are typing this in correctly. So I got 120 divided by 55. So going over to my calculator, what you're typing in first is 120, right? That's what you got to type in first, your numerator, divided by 55. And this is what I get. And since this number is not 5 or greater, this number is going to stay as 2. So for purple, I am making a prediction of 2. So I want you all to type in a complete sentence for this answer, just so that you really understand what you're making a prediction for, right? So I predict that there are, not 12, sorry, that's the frequency. What did we get? Let's go back. We got I didn't even put it here. It's in we rounded it to 2, right? So X equals 2. So this is my prediction. Out of the 10 pieces of paper, I predict that 2 are purple. So going back over here, I predict that there are 2 purple papers in the envelope. All right, so go ahead and try that out, scholars. Check your work. Remember, since there are 10 pieces of paper in the envelope, your 4 numbers should add up to a 10.